Example number 67. Using integration, determine the length of the curve. Using integration, determine the length of the curve. Y is equals to a half x squared. Are we together? Y is equals to a half x squared between the points. Between the points, x is equals to 1 and x is equals to 2. Are we together? So you've been told to use integration to determine the length of this curve between these points, okay? So you know very well that the length of a curve is given by you integrate between the given limits square root of 1 plus the derivative of that function squared with respect to x, because y is a function of x here, isn't it? Are we together? Y is a function of x. So if you know very well that y is a function of x, meaning where there is y you put f of x, isn't it? So your function of x is equal to what? Your function of x is a half x squared, because that is the y. Where there is y you put f of, because y is a function of. So we don't need function of x, we need its derivative, isn't it? So if you differentiate f of x, what do you get? 2 times a half? 1. You remain with x, isn't it?
Yes.
Then you reduce the power by 1, isn't it? Are we together?
Yes.
Power times coefficient, then you reduce the power by 1, so we differentiated that. We don't need the derivative, we square it. They need it square. We square both sides. So we end up with x. We end up with x squared, isn't it?
Yes.
Are we together?
Yes.
Isn't it? So after that, what do we now have? We now have, it means here, we are going to have what? We are going to have, if we are integrating from a to b, a is the lower limit, meaning a is this, a is 1, isn't it? And b is 2. So it means we are integrating from 1 to 2, then the square root of 1 plus x squared dx. If you look at that problem, you can see it is very simple. Anytime you see 1 plus this squared, that one is a case of the tan function, isn't it? Meaning we substitute tan. So we can say let x to be equals to tan t, meaning where there is x we are putting tan t, isn't it?
Yes.
So it means 1 plus x squared is going to be 1 plus tan squared t, isn't it? Are we together? See, 1 plus x squared, x is tan t, meaning x squared is going to be tan squared t, isn't it? Now if you look at 1 plus tan squared t, that is a Pythagorean identity. Sec squared. Are you seeing you are the one now enjoying this lesson more than everybody? It is sec squared t, isn't it? Are we together? But what do we want? We don't want 1 plus x squared. We need its square root, meaning we look for its square root, isn't it? Are we together? See, this square goes with the root. What do we remain with? Sec t. We remain with sec t. So it means when we are integrating the square root of 1 plus x squared dx, what are we integrating? We found the x. If x is equals to tan t, you differentiate x with respect to t, isn't it? Are we together? If you differentiate x with respect to t, what do you get? You get dx is equals to, when you differentiate tans, you get sec squared, isn't it? So you get sec squared td. When you differentiate tan t, you get sec squared t, isn't it? So dx over dt is sec squared t. You take dt the other side, isn't it? So you get dx is sec squared td. So it means when you are integrating square root of 1 plus x squared dx, it is like we are integrating the square root of 1 plus x squared. We found it is sec t. Then dx, where is dx? Dx, we found is the same as sec squared? Sec squared t dt. So in the end, you are integrating sec cubed t dt. you don't even need to transform it to sec cube t because you know you are still going to separate like this to be integration by parts, isn't it? Integration by parts. So you let one to be u and the other one to be v. Are we together? One to be u, the other to be v. So start. What is your u? Your u is the one which you can easily differentiate, isn't it? So you can easily differentiate sec t, and you can easily integrate sec square t. Meaning if you integrate sec square t, you get tan t, isn't it? So this is u dv, isn't it? U dv. So we want to integrate sec cubed t, which we found. We are integrating sec cubed t. Go on. If you integrate sec cubed t, you get u dv. So what is your u? Let's write it on top here. Sec cubed t dt we found is sec t times sec squared t dt, isn't it? So your u is sec t, meaning u is equals to sec t. Then what is du? If you differentiate sec t, you get sec t tan t, then your dt we just from this side, isn't it? Are we together? If you differentiate sec, you get sec tan. That is a standard differentiation, isn't it?
Yes.
Are we together? Then you go again, it means dv. What is dv? dv is sec squared t dt. So for you to get v, you introduce the integral of both sides, meaning v, if you integrate sec squared, you get tan t dt. The derivative of the inner function, which is a constant, is 1. So it's just tan t. The dt is not there, you've integrated. You have tan t over 1, which is just tan. Are we together? So what do you know? If you are integrating u dv, you are supposed to get uv minus integral of vd, integration by parts, isn't it? Are we together? When you are integrating u dv, you are supposed to get uv minus vd. So what do we have? U times v, can you multiply sec t times tan t? You get sec t tan, then minus the integral of what? Vd du. What is v? V is tan, and du is sec t tan t, meaning we have tan t squared now, isn't it? So it is now sec t tan squared t d. Are we together? Are we together? Good. So having done that, it is now direct. At that point, it is now direct, meaning this tan squared, you transform it to sec squared using Pythagorean identity, isn't it? We know very well that 1 plus tan squared t is sec squared. So if you take 1 the other side, it means tan squared t is the same as what? Sec squared t minus, meaning where you have this tan squared t, where you have this tan squared t dt, where you have tan squared t, you put its corresponding value, which is sec squared t minus 1, isn't it? Yes. Using Pythagorean identity. So can we now go? This side we have sec cubed t dt to be equals to sec t tan t minus, open this bracket, sec t times sec t, sec t times sec squared t. See, that is sec cubed t dt, then it is minus into negative is, are we together? So it is plus. So it is plus the integral of sec t dt. If we take this times this is sec cube, sec t times 1 is sec t, isn't it? Are we together? Then minus here comes to minus, minus into minus goes to plus, isn't it? So you can see this is the same as this. Are you seeing? See, this is sec cube t dt, this one is also sec cube t dt. So you now bring this side on this side of the equation, isn't it? Are we together? So you collect like terms.
Yes.
So negative sec cube t dt coming this side, so it becomes positive. This was having a coefficient of 1, this is having a coefficient of 1. So it is like negative 1 coming this side positive 1, so it's like 1 plus 1. There are now 2 of them, isn't it? So this side of the equation, we now have 2 sec cube t dt to be equals to sec t tan t plus integral of sec t. If you integrate sec t, what do you get? We did it the other time. When we integrate sec t, we were getting ln of sec t plus tan. We did it in standard integration of trigonometric function, isn't it? We were getting ln of sec t plus tan t. So you take to the other side, you get that the integral of sec cubed t dt, you divide everything by 2, isn't it? You divide everything by 2 is a half sec t tan t plus a half ln of sec t plus tan t. Then you bring back your limits. Are we together? Remember, your limits was from x was equals to 1 to x is equals to. See, these were the limits. Yes. Are we together? See, the limits we were starting from x is equals to 1 to x is equals to 2. 1 to 2, isn't it? And what did we say? See, we said let x to be equals to tan, isn't it? See, we said let x to be equals to tan t, isn't it? So what is t? This implies that t is the tan inverse of x. So the limits where you add x is equals to 1. So you ask yourself, when x is 1, what is t? Are we together? So that we get the limit, it was from 1 to 2 for x, but we now want limits for t, isn't it? So when x is 1, what is t? Tan inverse of 1. Are we together? What is tan inverse of 1? See, 45 degrees, which is pi over 4. Meaning when we were integrating x from 1, in terms of t, we are now integrating from pi over 4, because t is tan inverse of 1, isn't it? Are we together? Then move again. When x is 2, what is t? T is the tan inverse of 2, so that we get the upper limit of t, isn't it? Get me tan inverse of 2 in the calculator. 2. When x is 2, what is t? Tan inverse of 2. So change that 63 degrees into pi radians, because we are dealing with pi radians. Divide by 180. Answer, divide by 180. So you get 0.3. This is 0.35 pi, isn't it? Isn't it? Because pi is equals to 180 degrees, therefore 63 is equals to what? It is 63 times pi divided by 180. So it is 5 times the answer you found. Are we together? Are we together? So can you now go here and substitute? I've shown you how to get this limit. Meaning in this your problem, you put the limit is pi over 4, which is 0.25 pi, isn't it? Then here is 0.335 pi. So can you get me those? Can you substitute where there is t? Change the calculator to be in pi radians. Put the calculator to be in pi radians. Then you start with 0.3 pi is equals to what? Then you substitute a half sec answer tan answer plus a half ln of sec answer plus tan answer. We are substituting in the calculator. You've already changed it to pi radians. 0.35 pi. Yes. Good. Then go on a half. So just put half. Remember, sec t means over cos, isn't it? So you are putting a half in the numerator. You have just half. Instead of a half, you write it like this. Remember, let me show you how this is rewritten so that you don't confuse. A half sec t tan t, it means you have tan t in the numerator. In the numerator, you have 2 cos t, because sec is the reciprocal of cos. You can write press cos in the calculator, isn't it? Yes. See, this is now what you enter in the calculator. Then you go there plus a half ln of this means you put in the numerator ln of 1 over cos t plus tan t, then in the denominator over 2. Then you put your limits there, 0.25 pi, 0.35 pi. Your calculator, you must put in R for pi radians. So can you do it in that manner? Do it in that manner, start afresh. Then in the numerator we have tan answer over 2 cos answer. then plus in the numerator, let's put numerator. In the numerator we have ln in bracket 1 over cos answer 1 over cos answer. Move forward, plus tan answer. Close that bracket of numerator. Have you closed the bracket of numerator?
Yes.
Denominator you have 2? Yes. You will not close the bracket of the numerator. That is what I saw. Close it, double bracket, close the outer one. Yes. See, you reach there. Is equals to? You are done. 2.875. So we have there is 2.875. Then minus lower limit. 0.25 pi is equals to 0.25 pi is equals to. Then we play calculator to get up the answer for that. 1.4. 1.1. 4. 4. So if you subtract this from this, you get, what is your final answer for the length of that curve?
1.7.
1.783. Like that. What have you found? Upper limit minus lower limit?
1.7.
1.727. This is what you have. So you have 1.7227. So it means what is important here is when you are changing the variables, if x was ranging from 1 to 2, you say let x to be tan, meaning t is tan inverse of x, isn't it? So when x is 1, what is tan inverse of 1? You get the value of t at that point, isn't it? When x is 2, what is tan inverse of 2? You get the value of t at the other point. Then they must be in pi radians. Are we together? Good.